Hey everybody, this is Larry. This is day 7, I think, of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Yeah. I have nothing to say today, really. Waiting for this thing to load. I think at the end of the day, at the end of the day, you keep on grinding. The first thing you do is breathe. Because, listen, if there's one thing I learned from my marathons, is that you gotta keep breathing. Yeah, I know, it's maybe obvious, whatever. Breathe out, breathe in. You still got 26 miles to go, Yeah. Thanks for watching. Thanks for all your support over the whatever. It's kind of nuts, isn't it? What a time we live in. But let's take a look at today's problem. 2275, largest combination with bitwise n greater than 0, right? All right, let's take a look. The bitwise n of an array nums is bitwise n of all integers in nums. For example, for nums is equal to okay. You're given an array of integer positive candidates, the bitwise n of every combination of numbers of candidates. Each number in candidates may be used once. Honestly, I read the question, but I didn't read it, so let's read it again. It happens from time to time. Like, I don't know, different processing units in your head or something like this, right? Okay. Okay, so we look at every combination of numbers. I mean, each number can be used at once, but return a size with a larger combination of candidates and a bitwise n greater than 0. Okay, I mean, the first thing to notice is that n is 10 to the 5th, which maybe sometimes I feel like it's a little bit, not cheating, but like in a contest sense or even interview sense, but just like yourself of like thinking about the possibilities, right? I mean, I think I'm guilty of this as well, is that I'm guilty of looking at the result or looking at the constraints and be like, and catering my results to the constraints from time to time. But definitely, at some point, when you try to get better, it's important to focus on things that matter, right? With respect to just trying to improve yourself, right? Of course. Sorry. Getting a little bit of coughs. Honestly, not 100% today. So yeah, I don't know. It is what it is. Some days you're good, some days you're not so good. Yeah. And today, for this particular problem, you're trying to find bitwise n, right? And we're not trying to necessarily, we don't need to optimize for the bitwise n result, which is good because, I don't know, makes it a different problem. But it just has to be greater than 0. So the first thing I would ask myself is that, okay, what leads to a bitwise n going to 0, right? And the first answer that I would think about is that, well, a bitwise n of a set of numbers, but you start with 2 numbers, say, because there's this distributive property, right? Of m numbers is just one at a time, and you kind of go one at a time kind of thing, right? So and as a result of that, you can reduce it to a pairwise bitwise n, right? Or just not pairwise isn't the right word, but just like any 2 pairs, really. And bitwise n is exactly 0 when none of the bits matches, right? So that means that in the opposite of that, then we're trying to grade it to 0. That means that for every bit, and by what I mean by every bit is, I mean like the 1 bit the 2-bit, the 4-bit, the 8-bit, so forth, right? The binary bits. Well, there's they're kind of like I don't know if I would say this is greedy, but in the in the way that it's like almost like the least work that still satisfies greater than 0 is just having one bitwise or 1 bit shared across all the numbers, right? Like if you, and what another way to say that is that if your answer has 2 bits that are shared with all the numbers, and you could add a number that only has 1 of the bits, then you would do it every time because it doesn't change the bitwise greater than 0, but it would change the largest combination of candidates, right? So I think from that, I'm able to reduce this problem to just solving it. Okay, for every bit, and some of this is part math, and for int it's going to be 32, but even this is even smaller than that. 10 to the 7 is what, 10 million, and 10 million is what, like 25 or something like that, right? Give or take. So that means that if you try every bit of the 25 loops, you can test for yourself what is the bitwise and function of all the numbers that contain that thing, right? Because now you're just optimizing for the size, and now we only have 25 distinct possibilities of what bit we care about. I think that should be good enough. So let's kind of get started on this one, right? So maybe you can say like bits is equal to 0 times. I'm gonna still write 32 because I'm too lazy to prove things during a contest, or like, you know, just in general. But you know, 32 is the reason why I choose 32 is this the size of int. You may choose 64 if it's a long or 10 to the 18 type situation. But you know, it doesn't matter, right? And then now, and maybe I'll do b for bits, right? B is 32. Oops. And then now we can do for I in range of b, we can say if x mod, not mod, sorry, bitwise n of I is greater than 0, and all this means is that the ith bit of x is not 0, right? Which is a 1. I don't know why I said it like that, but yeah, to be more precise, right? And that means that here we can, for that bit, we can always care about it, so we can just increment it by 1, and that's really most of the answer. And then now we can just return the max of bits, and I think we should be good. If not, then we have a longer video. But yeah, I think that, apparently I got it last time. I don't remember this problem at all, honestly. I'm surprised that this is a little bit on the slower side, but I'm just curious what I got in the wrong answer. Oh yeah, I don't know what, I think I just did the math wrong. This number is just too big beyond 20 because, I don't know. So I think I just probably made it a little bit bigger and did it 30. But that's also why today I did it to 32, because I don't have to think about, like, I know that this is good enough for int. Sometimes, at least during a contest, and I don't know if this is during contest, but during a contest, you it was. That means that I would be very sad. 275. How did I do that contest? I'm just curious. So yeah, so that's a silly 5-minute penalty. Though I got 10-minute penalty on the Q4 anyway. But you know, yeah. So these are the things that you know, you feel a little bit sad about. So, and that's why, you know, you learn over time, of course, of like little silly things. This one not so much, but yeah. Anyway, but that's pretty much it. I hope I explained it okay, from kind of ground concept to how I arrived at the problem. Note that maybe I'm not as strict as the proofs. You can definitely try to prove it at home. But yeah, that's just how I kind of got to these places. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay healthy, stay good. To great mental health. I'll see y'all later and take care. Bye bye.